Okay, an athletic committee with 3 members is to be randomly selected from a group of 6 gymnasts, 4 weightlifters, and 8 long-distance runners. Determine the probability that the committee is comprised entirely of runners. So let's figure out our possibilities here. We have, they said there's 3 members. So in other words, there's 3 positions. Position 1, we'll call it position 2, and position 3. Okay. The number of people that we're drawing from is the total number of gymnasts, weightlifters, and long-distance runners. So if we add them all together, we have 6 gymnasts, so 6G, plus there are 4 weightlifters, 4 Ws, and there are 8 long-distance runners. So we're looking at 18 different people to select from. Okay. The very first question is asking us a committee comprised entirely of runners. So we're looking at 8 runners. So in the very first selection, it's a probability like this. We have an 8 in 18 chance of drawing a runner out. Okay, because there's 8 runners or long distance runners and there's a total of 18. Think of them almost like balls in a hat or something like that. The 8 of them are blue. We've labeled ours blue. 8 of the total 18 balls are blue. We have an 8 in 18 chance of pulling a runner. Now, the next time, number 2, there are now only 17 balls in, so we've drawn 1 person, but there's also only 7 long-distance runners. So this entire probability has changed here. Okay, because we've already drawn one of the long-distance runners, there's 1 less to draw from, there's only 7 guys. But there's also only 17 individuals to draw from because we've already selected 1 committee member. We're assuming this is kind of like drawing without putting things back, which would make sense. It's not like you draw a member and then throw them back in the pool. That means that member could potentially hold all 3 positions, which is not really what we're looking at here. And then finally, we would continue it. There's now only 16 people, but there are 6 long-distance runners. What's the probability that we have only long-distance runners? We're going to multiply these values. So I'll bring out a little calculator here to help us. Thank you. Here's my calculator. We have 8 by 7 by 6, so 336. Out of, and this is a large number of possibilities, there are 18 by 17 by 16 individuals, which gives us 4,896. 4,896. So this is the number that can be reduced, but in order to really, let's say the answer in the back of the book is some fractional answer, and we have to reduce this. One way to really quickly figure out these values is if we just divide these, whatever decimal, it should be the same decimal as the answer in the back of the book should be. So if I take these values and divide them, it should have a 0.0686. So approximately 0.0686, or in other words, approximately a 6.86% chance of having a committee of only long-distance runners. Another way that we could go about this question, like we said, is we do it as a permutation. So we have 8 long-distance runners, okay? So we're just going to build one fraction out of this probability, the probability of long-distance runners. There's 8 to choose from, and it does matter which person we choose, you know, whether it's person 1, 2, or 3. So that means this is going to be a permutation because the order that which they're chosen is going to matter here. 8p3 here. As our top value. So how many different ways can we choose 3 runners out of the total of 8? And on the bottom, the question is how many different ways can we choose 3 runners out of the total of 18 different people? So we're going to see what these 2 values get us. I'll bring up the little calculator again, but it should give us the exact same values. Let me bring up my functions. Here we go. Permutation. Okay. So we have 8p3 gives us the value of 336, just like you had pointed out before. And then 18p3, same thing, 18p3, 4,896, which is the exact same question. And if you understand it best this way, that's great. We can kind of go through it that way.